Hey, 8th grade, Catlin here with your algebra help for lesson 11. We're modeling these exponential behavior. We went outside, we dropped some balls out in the hallway, and as we were dropping them, we were measuring their height as they came back up. And this looks like another one of those tables. Every time that it bounces, it comes back up a different height. Notice that this table is leaving out the zero bounce number, so we don't know where it was dropped from. And that's I believe what they're wanting us to do and explain how we got that. So in this particular one, when it bounced once, it came back up 30 centimeters in height. And on the second bounce, it came back up to 6, third one, and then by the fourth bounce, it was pretty much non-existent. It was done. So what we need to do to be able to figure out the pattern here and approximately find the height that it was dropped from is we need to focus on the percentage of height that was lost from bounce to bounce. So what we did today is we kind of looked at these two from bounce to bounce, and we set it up as a ratio. Um, we only kept 6 of the 30 centimeters that we had to start with, so we would convert that into its percentage form. So if you're not good with fractions or reducing them or changing them around, you can always just divide them out in your calculator to get what that is as a ratio. We also know that's a fifth, so 20% makes sense. So it looks like to us that it's losing most of its height. It went from 30 to 6. I mean, that's a 20% growth factor or decay, right? So what does it do from 6 to 1? Well, it only kept 1 out of 6, and that's a little bit less than a fifth at 20%. Let's see what that turns out to be if we do 1 divided by 6. Um, 1 divided by 6 comes out to be about 17%. So 17%, pretty close to the 20 that was there. And then obviously 0 to 1, we're not going to do that percentage because it's not going to match our growth that we're seeing here. So we're going to take these two and use it as our basis. And I think we could probably meet in the middle and go with about 18.5%. So we're going to average these. These average out to be 18.5%. So that's going to be our growth factor that we use to kind of work down the table, right? 18 and a half, 18 and a half, that gets us where we want to go. So if we want to work backwards in the table, then we divide by that 18 and a half to go back to the zero bounce. So to go back up to the zero bounce, we're going to take 30 and we're going to divide it by our 18.5%, which would look like this in decimal form. So I'm going to do 30 divided by 0.185. So let me go to my calculator and do that. 30 divided by what we feel like our growth factor is going to be is point 185, 18.5%. So our guess is it was dropped from initially about 162 centimeters. So let's go back. Oh, wrong one. About 162. Now, we can try that out and see if, that's going to be, that's a lot of loss, but we saw that pattern as it went along. This is not a very bouncy ball. We saw a tennis ball today was like 53%. The dodgeball was around 75, 80%. So this is not a very bouncy ball. It's only keeping about 20% of its height every time that it bounces. So we're going to say from what height approximately, we're going to say we think about 162 centimeters. Explain your reasoning. Growth factor is about 18.5%. So to go back to original height or drop height, what did we do? We divided, to go back to the original drop height, we divided 30 by our growth factor of 0.185, 18.5%. And that took us back to 162 roughly. And that's how we do those types of problems. You got to find that growth factor by comparing the factors in the sequence. Once you got a good average or a good number that you feel about, you can work down the table by multiplying. You can work back up the table by dividing and get an idea where they dropped it from. and that's modeling exponential behavior.